Okay, chapter 3, day 5, what we're going to focus on today is how do we describe the distributions that we've been drawing. One of the things you're going to be asked to do after you see a distribution is describe it. Well, to describe the distribution, we are going to focus on 3 key things. The first one is shape. So, distribution takes on a shape. It could be symmetric, which is a distribution that if I were to draw a line down the center, it's approximately the same on either side. We might say it's skewed to the right. If it's skewed right, that means the tail heads to the right. It's kind of chopped off on one side, starts out really high, and then it tapers down and tails off to the right. We can say it's skewed left. So same thing, a big bunch is over here on the right, but the tail goes left. Two others that we talk about is uniform. So if you notice, there's really no tail and it's approximately about the same height the whole time. We also talk about unimodal, having one mode or one peak. Two peaks, bimodal. Okay, so this one doesn't have to be necessarily the same height as this one, but approximately there's some sort of peak, and then there's a lull in the action, and then a peak again, and that's bimodal, bi prefix for 2, and multi would be 3 or more. So what is the shape? Is it symmetric? Is it skewed? Is it uniform? Is it unimodal, bimodal? So you'll kind of talk about symmetric, skewed, and then how many modes does it have? Unimodal, bimodal, multimodal. We want to talk about where it's centered, around the center of the data. Now, if we're talking about the mean or the average, we're talking about the balancing point. Where does this distribution balance? So if I'm up here, where does it balance? That's about the mean. All right. If I'm here, where does it balance? That's the mean. So the mean is another word for average. It is the balancing point. Now, it's better used for symmetric distributions. The reason why is this. If I tell you that the mean of this data is right in here, or the average, that makes sense. But if I'm over here and I say, well, on average, people get about this value. Well, that's not really what the data is. Majority of everyone is back in here, but that wouldn't be the average because that would not be where the balancing point is. So when I use the word average, I like to use the word average when I'm dealing with symmetric data. I could talk about the median or the middle value, and that one I use when it's a skewed distribution. I could still use median for symmetric, but I like to use it definitely though if the data is skewed. I say, well, the median is somewhere around in here. It's about what the middle person is doing, the median, all right? So median is the middle value. It's better used when we have skewed distributions. The average is better used when we have symmetric distributions. The median is resistant, though, to outliers, and that's important to know. And what do I mean by that? Well, let's come back up here to our skewed distribution. We have an average. If I were to put another piece of data on here, like way out here, it is going to drag the average out towards it. The average will change with an outlier. But the middle number isn't going to change much if I add one piece of data on the end. The middle number is still the middle number. So even if that piece of data was way out here of this whole thing, the middle number is still the middle number. It does not change. It's resistant to an outlier. Mode is your most frequent. We don't really talk about the value of the mode much. We just talk in terms of, does it seem to have one mode, two modes, or three or more modes? The spread, how much the data is spread out or compacted, how much does it vary around its center? So if you notice, here's two distributions, center, and this one is really tight around the center, and here's its center, and it's spread out around the center. This would have a larger spread, this would have a small spread if we were comparing them. And unusual features. There's a fourth thing that we talk about, unusual features. Are there any gaps? Are there any outliers? So, for example, here's a situation where we have a gap, we have no data, but this isn't necessarily an outlier. Here is a gap, okay? This value is an outlier. Here's a situation where I have a gap, but I wouldn't really call this an outlier now. It's closer to this data, all right? But if it's way out here, away from the data, then I would call that an outlier. So I want to talk about gaps and unusual features, and notice not every gap is an outlier, and I want to talk about any outliers, anything unusual about the data. So again, when I describe data, I want to talk about the shape, symmetric, skewed, uniform, okay? Is it unimodal, bimodal, multimodal? I want to talk about its center. Does it appear to have a mean of a certain value or a median of a certain value? I might not know the value, I might know an approximation from a histogram, but when would I use mean and median is also something important to know. How much the data is spread out, small or large spread, and are there anything unusual about the data? Any unusual features? Are there any gaps? Are there any outliers? So that is describing data.